All right, these are the answers to section 1.4. We're asked if the following things are functions or not. In a function, each domain would only go to one range. So in this case, the -2 goes to 3, that's fine. The 0 goes to 4, that's fine. 1 and 2 both go to 5, that's fine. They can go to the same thing. They just can't go to multiple things, and this is the problem right here. This -1 is going to 3 and to 4. It can't make up its mind, so we would say this is not a function. All right. In this case here, each input, 0, 3, 9, 12, 15, they're heading to the same thing, but again, that's okay. They can head to the same value. They just can't go to multiple. So you couldn't have 0 show up later and head to something other than 3. The fact that they all go to the same thing, that's fine. This is a function, at least as far as we can tell right here. All right. Now, they give us some functions here on number 26. G of y is 7 minus 3y. What they want you to do is just put this value in for y and then see what the function would equal. So if you put 0 in for y, 3 times 0 is 0. 7 minus 0 is 7. So we get a value of 7 for that. If we put 7/3 in, 3 times 7/3, the 3 and the dividing by 3 would cancel. So 7/3 times 3 is 7, and then 7 minus 7 would give us 0 for this. So again, that 3 is going to cancel the 3 that's on the bottom here, leave us with that 7, and then the 7 minus 7 gives us 0. Now this s plus 2, that's a little strange, right? We're going to put that in for y, and so we'll write this out so that it's a little easier to see. So instead of that y, this s plus 2 went right into that spot right there. The y goes away, s plus 2 goes in place. Now what we're going to do is we're going to multiply by -3. So this -3 is going to come in and multiply. So the 7's right there. We got -3 times s, which is a -3s, and then -3 times 2 will give us a -6. Now to clean this up a little bit, 7 minus 6 is 1, and then the -3s is going to stay there. So if I put s plus 2 in, that's what I'm going to get, 1 minus 3 times whatever s is. Got another function here, absolute value, one to play with. So if I put 2 in, the absolute value of 2 is still 2. Absolute value just makes it positive. It's the distance you're away from 0. So 2 plus 4 will give us 6 for that. If I put in -2, the absolute value of -2 is +2. -2 is 2 away from 0. So 2 plus 4 will still make that 6. And then if I put x squared in, the absolute value of x squared, well, x squared, since it's squaring something times itself, that'll always be positive. And so the absolute value of x squared is still x squared. And then we'll just go plus 4. Again, anything times itself will be positive, so the absolute value won't really do anything to that. Now, if this had been x cubed, that'd be a little different story. We'd have to consider what that x is, but we can be sure that x squared is always positive. Now we get this piecewise function, and it's telling us that based on what value of x you want to use and work with, the function is going to do different things. So if I want to work with -3, -3 is something that's less than -2, so I'm going to put the -3 into this top one. We're going to go 4 minus 5 times -3. And so if I think of this as like -5 times -3, that's 15. 4 plus 15 would give us 19 for a value there. Okay. I'm looking at f of 4. 4 is bigger than 2, so I want to put 4 in here. I want to go 4 squared plus 1. 4 times 4 is 16. 16 plus 1 gives us 17. Okay. And then -1 is between -2 and 2, so I'm going to put it in here, but there's nothing to put it in. It just simply says anything in between there, the function is simply equal to 0. For 42, we get this one. Now, this is a very popular one on the AP test. I'm not sure why they're in love with this kind of function, but they are. And when we put things that are less, so you can see that 2 would be an issue, right? If you put 2 in, you're going to get 0 over 0, and that's something that we're not quite sure about. So if we put something that's less than 2, like if I put 0 in, I get the absolute value of -2. The absolute value of -2 is 2. But if I put 0 on the bottom, I get just -2. So you're going to get 2 over -2, which gives you -1. And the thing is that anything that's less than 2 does the same thing, right? If I put 1 in, I get the absolute value of -1, which is 1 over -1. That still gives me -1. If I put 3 halves in, I'm going to get the absolute value of -1/2, which is 1/2. divided by -1/2, I get -1. So all these values that are less than 2, every time I put them in, I'm going to get -1 for a value there. But as soon as I put something bigger than 2 in, say 5/2, absolute 5/2 minus 2 is 1/2. The absolute value of that is still 1/2. And I'm going to get 1/2 on the bottom. I'm going to get 1/2 divided by 1/2, which is a positive 1 now. If I put 4 in, absolute value of that would be 2 over 2. 2 divided by 2 is 1. Now anything that's bigger than 2 is giving me positive 1 for that. And again, if you want to see what that kind of thing looks like, so coming up to 2, we're equal to -1 down here. And then we have an open circle, and then an open circle, and then we're equal to positive. We kind of jump up. And at 2, we don't have a value. There's no function value for 2 in this case. And like I said, the AP calculus test, they kind of like this equation. I'm not sure why, but next year we'll talk more about that. All right, 44, again, a piecewise function, things for less than 3 or greater than or equal to 3. So if you're less than 3, like 1 and 2, you're going to go into this function here. So 1 squared is 1, 9 minus 1 would give us 8. 2 squared is 4, 9 minus 4 would give us 5, okay? But if you're equal or greater than 3, then you're going to go into this function here. So if I put 3 into there, 3 minus 3 is 0, 4 minus 3 is 1, 5 minus 3 is 2. Again, these numbers went into the bottom. The other numbers went into the top based on the definition there. Okay. And then 60 and 66 want to talk about the domain for this function. Now, domain is the list of all the values we can put into a function. That's usually lots and lots and lots. The easier question to answer when you talk about domain is what can't I put in? What are the things I'm not allowed to put in? And really the only things that are going to cause issues for us is if the denominator is equal to 0 or if we get a negative under a square root. Those are 2 no-nos that we can't do. In this case here, I see that I've got y plus 5 on the bottom. The only thing that's going to make this 0 is if I put -5 in for y. -5 plus 5 would create 0 on the bottom. That's a big issue for us. So our domain is all y values that are not equal to -5. So when we say this, we're saying y can be anything it wants, anything at all. It just can't be -5. That's the only value it can't equal. Why? Because it would make the denominator 0. We can't divide by 0. Same idea here. If we take x squared minus 2x, you could do this one of 2 ways. The way I would like to look at it is just pull this x out, like factor it out. If we were to distribute, we'd get right back to there. But this makes it a little bit easier. Now, one thing I can't equal is 0. 0 times this would be 0. That's going to cause a problem. The other thing I can't equal would be 2. 2 minus 2 would be 0, and that would create a problem. And you can go back to the original and see 0 squared minus 2 times 0, that would be 0, or 2 squared minus 2 times 2, that would be 4 minus 4, that would be 0. So again, x can be anything it wants. It just can't equal 0, and it can't equal 2. Those are the things it can't equal. It can be anything else it wants to be, but those are the values it can't be.